Uh, so, Good evening, everyone. Um, Welcome to the week 5 session of NPTEL Bioreactor Design Analysis tutorial session. So, I'm Fanita Hafsiba and I will be assisting you with tutorial problems today. So, let's wait for 2 to 3 minutes for others to join. Then we will start looking into the some problems and some few questions. So let's go to our first question. Um, so the question number 1 is a microbial strain is cultured in a 100-liter stirred-tongue fermenter for secondary metabolic production. The specific rate of oxygen uptake is 0.4 R inverse and oxygen solubility in the broth is 8 mg per liter. Determine the volumetric mass transfer coefficient in second inverse. Uh, so the mass transfer coefficient of the oxygen required to achieve a maximum cell concentration of 12 gram per liter. So we have to calculate the KLa to achieve a maximum cell concentration of 12 gram per liter. So how we will proceed with the problem? First we will start noting down the given values. So volume is given as let's keep V is given as 100 liter. Your specific rate of auto uptake, that is Q O2 is 0.4 R inverse. Oxygen solubility to what we will denote it by 8 mg per liter. We convert this to gram per liter, which is 8 into 10 to the power minus 3 gram per liter. So the maximum cell concentration, which is X max, 12 gram per liter. Okay, so how do you proceed with this? What is the formula for KLa? How do we calculate KLa? So we know that at steady state, specific rate of oxygen uptake, which is QO2 into your X, will give KLa. So means for I hope you remember this formula. So for a given bioreactor operation, maximum rate of oxygen um, transfer occurs when the concentration difference, that is the concentration, the driving force, which is this part, C star AL minus CAL bar is highest. When keeping that in mind, if to keep this difference highest, we have to keep this 0, means CAL equal to 0. So if we substitute CAL equal to 0 in this equation, then it becomes QO2 into X max equal to KLE to star. So this we have to substitute the values. So what is the value of QO2? It is 0.4, into X max is 12 gram per liter. KLE we don't know, and CAL star is 8 into 10 to the power minus 3. 8 into 10 to the power minus 3 gram per liter. So we cross multiply this, KL will become. So what would be the answer? Please follow. I'll wait for a minute. Please let me know the answer. Make sure the units are correct. Check the question. What if any specific unit is mentioned, you have to give the answers in the same unit which is asked in the question. So the answer would be around 0.6 R inverse. So what is the question? So the question was asked for the KLA should be in terms of second inverse. So if you want to convert your hours in seconds, what do you do? The answer. So we'll go to the next problem. Okay, so this question, a simple question. Hope you remember the uh, lectures related to rheology of fluids. So here the question: a scientist, while performing a fermentation experiment, observed that the properties of the culture medium changed during the process. So it now could not flow freely until a threshold stress is applied, after which the shear strain increases linearly with the shear stress. Such behavior is observed in which of the following fluids? So you have been given four options. So what is the option? Do you think it is the correct? It's the correct one. So basically, the fluid could not freely flow until a threshold stress is applied, after which the shear strain increased linearly with the shear stress. So to which of the following fluid this condition is applicable? So let me start. So you would have come across this. This is your shear stress. And this is your rate of shear. So Newtonian is here. Your shear thickening, the shear thinning, these are being a plastic. So can you now tell from which of the following option is true? The other name for this is pseudoplastics, shear thickening, where the fluid which has shear thickening effect when you furthermore increase the stress would be called dilatants. So what is the answer? So it's not coming under shear thinning effect, which is pseudoplastic, nor the dilatant. So it doesn't obey any Newtonian law, so it is not a Newtonian fluid. So the answer would be Bingham plastic fluid. So this is the next question. So you can take a minute or two to read the question and understand what the question is about. So the question number 3 is: determine correctness or otherwise of the following assertion A and reason R. So the assertion A is: in agitated bioreactors, the retention time of gas in the broth is minimized. The reason R is given as: one of the major functions of the agitator is to drive the gas bubbles to the bottom of the bioreactor. So out of the 5 options given, what do you guys think would be the correct answer? Whether the assertion A is true or the reason R is true or the combinations. So here are the options. Please take a minute or two to read the question carefully and let me know the answer in the message box. So let's start looking at the options. So both A and R are true, and R is the correct region for A. So what is A? It states that in agitated bioreactor the retention time of gas in the broth is minimized. Is it true? No, that's not true. So the option A is invalid then the option B is also invalid. So option C is A is true but R is false. Let's see whether R is false. So reason R is one of the major function of the agitator is to drive the gas bubbles to the bottom of the bioreactor, which is true. So the option C would be false, and your option E is going to be also false. So the correct answer is D. It's A is false, but the R is true. So shall we move on to the next question? So the question number 4 is, which of the following correlation is true for given flow regimen and impeller design? So we have been given lectures on power number, laminar flow, turbulent flow, Reynolds number, how they are correlated. So think about those correlations and answer this question. So take a minute or two to understand the question, and please type the answer in the inbox. I'll wait for 2 minutes and then we'll give the answer. So what is power number? Power number is 4 divided by diameter in the dia. So the options are, for laminar flow, the power number is inversely proportional to Reynolds number. For turbulent flow, power number is constant for a given type of impeller. So this would be the, for turbulent flow, power number is directly proportional to Reynolds number. No. For turbulent flow, power number is constant for no. These both are the answer. So coming back to a question which is similar to the third question. So question number 5 is, some types of fluids exhibit time-dependent properties. The following figure demonstrates how the apparent viscosity nu varies with time for fluids A and B. Choose the correct option that follows the behavior shown in the figure given below. So you have been given options and you have to identify what is A and B. So what does this denote? As the time increases, the property of the fluid is changing. So choose the correct option. just given below. So you know what dilatant, pseudoplastic, Newtonian, non-Newtonian, thixotropic, rheopectic, etc. Right? So let me go back to the same picture here. So what would be the answer? I'll give you 2 minutes. Try to remember the lecture and answer the question. So we know it is the graph doesn't even look similar. So it is not this, it is not this, it is not this, non-Newtonian, Newton, no. So it would be any of these. So what is thixotropic? Thixotropic. So thixotropic means the viscosity decreases with stress over time. So if you think thixotrop, what is here? The viscosity decreases with the time. So rheopectic is viscosity increases. See, note here your shear has stopped over time. So if this is the case, the answer would be A is rheopectic and B is thixotropic, right? So the next question is bulk oxygen concentration in the culture broth in a bioreactor is determined by the rate of oxygen consumption by the cells. So is this statement true? It is true. The bulk oxygen concentration in any culture broth in the bioreactor system is determined by the rate of the oxygen consumption by the cells being cultivated in the reactor. So the next question is, for an immobilized particle, if the dam molar number Nd is less than 1, the mass transfer rate is much greater than the reaction rate, and the overall reaction is controlled by the enzyme reaction. Is it true or is it false? So what is dam molar number? Yes, Sonam, the answer is A, which is true. So we'll solve tutorial problem. I think this solved already. I don't remember exactly. Solved in the tutorial. So a 20-liter stirred fermenter containing a bacillus thuringiensis culture at 30 degrees Celsius used for the production of microbial insecticide, and the KLA is determined using dynamic method. So the airflow is shut off for a few minutes, and then the dissolved oxygen level drops. The air supply is then reconnected. So when the steady state is established, the dissolved oxygen tension is 78% air saturation. So the following results are obtained. So in this table, the results are given. So now we are asked to estimate the KLA value, and an error is being made determining the steady state oxygen level. So instead of 78%, it is taken as 70%. So if error has been noted down while measuring the KLA, what would be the percentage error in KLA due to this 10% error in the, it is actually CAL bar. Okay, so let's please copy down uh, the given values, and then we will start with solving the problem. I hope you remember this problem. Let me write down the given values. So CL is given as 78% air saturation. Right. And time is 5 and 15, and the oxygen tension is 50 and 66. CL time 1 is 5 seconds. CL1 is 50. Time 2 is what? It is 14 seconds. CL2 is percentage. So you know it is dynamic gassing method. So the formula is Um, if I substitute this, what would be the answer? Please solve and let me know the answer. It is ground. So your KL is point. So the KL is 0.0847 second inverse. So this you got for which one? So you estimated the KL which is 0.0804 second inverse. So it is in your question B, it was told that while measuring the steady state oxygen level, they measured it instead of 78, they have taken it as 70%. So instead of substituting 78, please substitute 70 and see, and you will get a KLA value, and then you have to calculate the error. So the question really asked was what is the percentage error in KLA resulting from this 10% error, which is almost 8% difference is there. So it is rounded off. So it is like almost around 8 to 10% error is made while calculating this. So how does it affect your new KLA measured? So to calculate that, the same formula, substitute instead of 78, you substitute at 70 and calculate the KLA value. Then we will see how to do that. So this is your new KLA. So what is the error? Sorry, this is not. So the error almost looks like here this is 0.16. So it is 0.1609. The other one is 0.0 approximately 80% error is there. So if we do any error in measurement, so this much difference would be made. So that is what while calculating your KLA or measuring your steady state oxygen level is it is very crucial. So while measuring, we should be very careful, and it is not an easy task also. So the question number 9, I think you are aware of this question. Like a similar problem you would have solved. So the question 9 is the dynamic method is used to the same dynamic method is used to measure the KLA in a fermenter operated at 30 degrees Celsius, and the data for the dissolved oxygen concentration as a function of time during the reoxidation step is as follows. So the data is given. So you are asked to determine the value of KLA if the equilibrium concentration of oxygen in the broth is 7.9 into 10 to the power minus 3 kg per meter cube. So here your CAL bar concentration is already given. It is not 8, it is given as 7.9. If it is not given anything, you have to assume as 8 into 10 to the power minus 3 gram per liter. So here it is not given, it is given already. So you have to take that into consideration. So read the question once or twice and come up with how we can proceed with the given values we have, how we can proceed ahead to solve the problem. So I'll give you 2 minutes to read. Please go through the problem, and then we will start by noting down the given values, and we'll start solving the problem. So this value is 0.847. When we do the error, it would be we'll solve this last at the last. Start solving the problem. So, um, so in your dynamic method during the reoxidation step, how you would have come across this OTR minus OUR, we keep it as 1, and OTR is what? It is KLA, C star AL minus CL, and what is your OUR? It is your quick rate of oxygen. Take it to mass. So let's keep it as equation 2. So when the dissolved oxygen concentration reaches a steady state, which is the steady state value of CE bar CAL, at this state when it reaches the steady state upon the CAL will equal to CAL. So at this time your DCAL by dt, that is the difference, would be 0 because there is no change in the CAL with time. Thus the equation becomes OTR equal to OUR. Now if we consider this in equation 2, so that equation 2 becomes C star AL minus CL go to X, which we will keep as 3. So now we have to simplify the equation. how do you simplify it? I think you guys know this. You should know to derive this. So let's substitute equation 3. From equation 3 we found our QO2x value, so we are substituting it back there. Minus your equilibrium value. Okay, so how do we simplify this? Take common. Multiply it on both sides. If we do that, then we will get the same expression we were using previously. So if we get our t to the side, so the expression would be okay. So this is the expression we were using before. So we just derived the equation. There are a few steps which I have missed. There are common steps only, so you can solve. Try try deriving those steps also. So if we go back to the question has the time intervals. You have got the t values. Also, your from this what you can find when it your air saturation has reached means this is what this value can be taken as your CAL part. So if we do this and as taking this as CAL1 and this as CAL2, similarly if you keep on doing this, like keep this is CL1 2, like this, if you keep on doing it, and this is T1 and T2, if you keep on doing that, you will be you should be able to calculate in a table. Table is ln of C bar minus 3. Okay, so first value is already 0, origin points we will keep. So how do we calculate this? This and this, if you take, your T2 is 15, your T1 is 10. So this is 5. For the same time interval, calculate this value. So means this is CL1, this is CL2. Ln of 73.5 minus CL1, right? 43.5 divided by 73.5 minus 53.5. If we do this, we will get a value which we can fill in this tabular column. The same way you have to repeat. You find the values and then you have to plot a graph. With that, you will, from the slope of the graph, you will be able to find the value of KLA. So we'll start filling the table. What would be the answer? So the answer would be 0.41. Similar way, you have to keep filling this. I'll keep this table. I'll give you 5 minutes. So fill the table column. Yes, this also. What is the next? T1 and T2? 20 and 15, right? 20 minus 5 is the interval is again. So solve this in similar way and please fill the table. I'll give you another 10 minutes to fill the table. So then we will proceed. So what would be the answer of this? This is 10. So 0.8 and 10, you can fill it here. I have filled the t values and fill the x-axis value, which is ln CL bar minus CL1 divided by CL bar minus CL2. Calculate those and fill this in this, and then we will see how we can plot the graph. So by looking at the axis only, we will be able to see. So this will be your T2 minus T1. This will be your ln of CL. So we had filled this, but due to some glitch, I have lost the data. This is around 1.6. So what would be the next data? 2.3. We'll solve the last two. Solve for this. So solve this and let me know the answers, then we will see how to solve the graph. Okay, now so you have got the values of your x-axis and your y-axis. You have to, if you have a graph paper, use it to, or later on after the session also, you can use a graph sheet to plot the data. For example, for in case it is at increments of 5 means, and this is at the increment of 1, 2, 3, 4 means, for your 5, the time of 5 interval, t2 minus t1. Your point should be somewhere here. So here, so there will be a line which goes on, a straight line. So if you take slope to any 2 points, you know, right, dy by dx is slope equal to KLA. So this slope value will give you the value of KLA. For this sum, approximately the values would be, if you solve it in the graph, from the slope we can calculate it around 0.069 second inverse. So please go to, use a graph sheet and try solving at your free time. So this would be the answer of the sum. So let's go on to the last question, which would be, I'll read out the question and have a minute or two to read the question, and then we will try solving the question also. So the question number 10 is, 18 millimeter cube fermenter is used for the production of biocellulose from the bacterial strain of Bergerinia indica. Under the current operating conditions, KLA is 0.25 second inverse. The oxygen solubility in the broth is approximately 8 into 10 to the power minus 3 kg per meter cube. The specific rate of oxygen uptake is 10.5 millimole gram inverse R inverse, and determine the maximum possible cell concentration, and note in terms of gram per meter cube. It is asked in gram per meter cube. So when you convert the data, it should be in terms of grams per meter cube. The answer should be. So we can wait for 2 to 3 minutes, read the question and understand how to solve the problem and what formula to be used, and then we will solve it in 2 minutes. solid that which is in star gas. So first we will start by converting this specific rate of oxygen uptake rate into so we'll start for the steady state. What would be the equations is your uptake into your KLA of that. Sorry. To a steady state, your Q2 into if you substitute as L bar is equal to 0, which is KLA C star AL, that is the case, your X max will remain here. And you are asked your biomass, right? Maximum cell concentration. So, so now substitute things kg per meter cube. It is in kg per meter cube. You want it in grams per meter cube. So, if that is the case, millimole, right? It is grams per hour. But here it is in seconds. So for converting to second, you are converting it into 60 into 60, which is 3600 seconds. One gram mole divided by 1 millimole is equal to 10 to the power 1 gram mole 10 to the power minus 3 millimole. So 1 gram is equal to 10 to the power 3 millimole, right? So this is the conversion sake we are putting, and gram mole to gram, the oxygen's molecular weight is 32. So 32 gram per 1 gram mole. So if you solve this, we will get the answer of your X max. So I'll wait till you guys solve the X max value. So what would be the answer? It would be around, the answer would be around 2.14 gram per meter cube. So this is the value of the maximum biomass production. So that's all. So this is your maximum biomass production. The answer is 2.14 into 10 to the power 4 gram per meter cube. If you had trouble um, converting those units, please do it doing your substitution, so that it will not confuse you more. So that's all. If you have any doubts, you can ask me now, or if you have any other doubts related to this problem solved or questions, you can ask in the discussion forum, stating that it is from the live session held on the date, along with the date. So if you have any doubts, you can ask. So if you have any doubts, you can ask or you can leave the session.
Thank you, ma'am.
Thank you, sir. So, if you have any doubts, please send a send your questions to the discussion forum, mentioning it is from the live session tutorial, mentioning the date of the session, so that we will be able to get back to you at the earliest. So, if you have, if you don't have any other doubts, you can leave the meeting. We are solved. So this material, the PPT will be. I hope it is being shared with you guys, and I hope this session was useful in solving some of the problems related to the week 5 lecture. So I've shared all the books, which is Bioprocess by Paul and Duron and Schuler and Carty, in our drive. So if you have not received, um, please check with NPTEL team so that they will be providing you with the link. So that's all for today's session. Thank you for joining. We'll meet in the next class.